the boards on the coffee table in the living room while she watched The Gong Show. I'm pretty much the person who built most of the Macintosh prototypes. There was just no access to technology the way we have it now. The Apple I was a watershed event in terms of price and capability and the average person being able to own this computer. The Pine 64 is an improvement beyond my wildest expectations.
Introducing the Pine 64. The Pine 64 is a fully expandable 64-bit quad-core single-board computer with a 1.2 GHz 64-bit ARM Cortex CPU, 2 USB ports, an Ethernet port, and a full 4K HDMI output. The Pine 64 has everything you need to build your next project. Purchase the basic unit to run Linux or Android, or add on components to create your own custom computer. We're constantly developing new modules for the Pine 64 platform, such as a 5-megapixel camera, Bluetooth 4.0 and Wi-Fi card, lithium battery, or even an LCD touch panel, just to name a few. The Pine 64 also has 2 I/O expansion ports, compatible with many other components, such as Z-Wave, Zigbee, and X10.
For the price of a meal, the Pine 64 is a fully fledged computer. It's versatile, it's modular, and it's more powerful than most of the competition on the market. We at OpenHub are excited about the endless possibilities that the combination of the Pine 64 and OpenHub can bring. So having really a board that works well with OpenHub is really a perfect starting point for many more users. And it means that smart home technology becomes more easily accessible for everyone.
With access to over 1.6 million Android apps on the market today, the Pine 64 really can be your most affordable 64-bit computing platform. Run Office apps, watch full 4K videos, stream from apps like Netflix, and play games or more. We're fully compatible with Android Lollipop 5.1, Ubuntu Linux, OpenHub, and more.
Be one of the first to join the Pine 64 community. And with your help, we can create more modules and software to bring affordable computing to all.
Would we have ever believed we would have this $15 supercomputer? No, I wouldn't have believed that. It's a big step just from the Raspberry Pi to the Pine. It's still hard to believe that it's so cheap.
Hi Kickstarters, I'm Lauren.
And I'm Matt. We are the Latte team, and this is our latest product, the Latte Panda.
We are makers, we love making and hacking things. But so far, we haven't found any suitable tools for Windows-based projects.
So we created Latte Panda, a palm-sized quad-core full Windows 10 computer, and it runs perfectly with you. Using Microsoft Office, playing high-definition videos, and running other Windows-compatible software on the Latte Panda is exactly the same experience as using a regular PC. And it's way smaller. In fact, it's 40% smaller than an iPhone.
But just like an iPhone, it includes Wi-Fi and Bluetooth 4.0. It's very affordable to run, using a regular 5V phone charger for power. To make it suitable for a wide range of user scenarios, Latte Panda also comes packaged with an Arduino-compatible coprocessor. With existing open-source APIs, you can build your own software or hardware projects and then share them to our community.
We are a small team of engineers and hobbyists based in Shanghai, each with specific skills. Supported by DF Robot, we have an array of hardware and software resources at our disposal. We love tinkering with hardware, and we are very excited to share our creations with you.
Jaguar Board is a standalone x86-based single-board computer. You don't need to learn ARM for using it. Just enjoy it like playing with an x86 computer. Generally, Jaguar Board is designed for better performance on system scalability and compatibility. It can support 1 GB memory and 16 GB eMMC flash. Jaguar Board has a variety of interfaces. There are 1 network port, 1 audio port, 3 USB ports, 1 HDMI port, 1 TF card port, 1 power supply, 4 COM ports, 2 volume control buttons, and 1 switch. Jaguar Board is based on x86 architecture. We have used low power consumption Intel CPU. This means more powerful capacity and faster speed than other single-board computer. Besides, Jaguar Board provides more options for operating systems. It's compatible perfectly with the mainstream versions of Linux. You can install Ubuntu, CentOS, Fedora, Debian, and it can also support the latest Windows 10 and Android system. Basically, Jaguar Board can be used as a mini PC. The first step is to connect it to an HDMI displayer, a keyboard and a mouse, then you can easily use it, just like playing with a PC or laptop, to play online games or work with emails and office software. Or you can turn it into a fantastic home theater PC. Use the board as a video box. Even more, using your imagination, you can make a mini Linux networking server, a temperature and humidity monitoring system, or even your own smart home system. Jaguar Board is such a single-board computer, similar to Raspberry Pi. But the difference is that it is based on x86 architecture with better performance. We hope to provide a cost-effective choice for all embedded system engineers, developers, DIYers, and students. It may become more powerful with your secondary development. Hope you like it and enjoy the experience with Jaguar Board.
This is CHIP, the world's first $9 computer.
Connect over composite, VGA, or HDMI.
CHIP does computer things. Save your documents to CHIP's onboard storage. Surf the web over Wi-Fi. Play games with a Bluetooth controller. But wait, there's more.
This is Pocket Chip. It makes CHIP portable. Take CHIP, put it into Pocket Chip, and you can use CHIP anywhere.
You might have noticed, CHIP looks a little different than every other computer.
Because we built CHIP to fit into your projects.
And we're so excited to see what you can do with a $9 computer. Kickstarter, we need your help. To make CHIP for $9, we need to buy components in extremely large quantities. Help us make the $9 computer a reality and back CHIP on Kickstarter today. Thanks.
Doing single-threaded computing, having one processor running one task at a time, and that's worked great. But then we hit a frequency wall, and then we hit a memory bottleneck, and things just stopped. So what we've seen for last year, really performance hasn't improved as much as it should. We're now stalling, and if we don't do anything about it, all those great strides we made over the last 30 years, when things would get better every single year, they're going to stop. And the answer to that is parallel computing. It's the only way to really scale in terms of energy efficiency, performance, and cost. I've been in the chip industry for 15 years, founded a company in 2008 called Adaptiva, and we've been designing parallel chips, and that's what we do. We're hardware designers. We love designing chips, low power, they're simple, easy to use. We've been doing this for 4 years now. Had great traction in government labs, corporate labs, universities. The obstacles to really make parallel programming ubiquitous and everywhere is you need available hardware that's parallel. That's the first step. It needs to be open so that people can really study it, understand it. It can't be a black box that you give some work to and just does things magically. And with time, things have gotten more and more closed down. When you close down the system, really what you're asking for is for a company to do all the work for you, or most of the work for you. You get a sandbox to play with, and basically are told, don't try to think, don't try to innovate and make it better. If you do open up the architecture, somebody will come up with a better way of doing things. It's worked great for open source software, right? I mean, over the years, and we want to do the same thing for hardware. If you're going to have a very expensive platform that's closed source, that is tied with NDAs, then you're only going to reach a very, very small audience. We're going to provide a $99 kit that's going to be completely open source tools, free tools, lots of performance. And we think that's really going to enable the next level of computing and educate the masses of how to do parallel programming.
With this kind of processor, I can really stretch the kind of research we are doing, implementing, say, optic flow or visual information relating to changes in the visual input as you move around. If the hardware is not powerful enough, the frame rate at which you can calculate the image is too low for a robot, for instance, to navigate efficiently in the environment. So having lots of powerful processor will give us the chance to implement optic flow, object recognition, navigation, path planning, higher cognitive functions, a variety of things that today we cannot even dream of because there is not enough computing power.
Our first audience are the developers, the guys who really want to study parallel programming, maybe the guys who want to create a great application but doesn't have the performance to do it today in an embedded environment. But the second tier after that is the guy who just wants an awesome computer for $99 that has more performance than anything else out there. We've had lots of people interested in our platform, but our price point has turned them away. Thousands of dollars today is too much for somebody to do research. Everybody is constrained by cost, by their funding. Anybody should be able to afford a $9 kit if they're doing research. Big thing about making the kit cheap enough is this idea of producing a chip in volume. And for that we need money. So we build prototypes today that are fully functional products, but we just don't have the tooling, the factory set up to produce these things for a couple of dollars. Today, they cost a few $100s. With this funding, we can bring them down to a couple of dollars per chip. If you want this platform, we're asking you to basically pledge to the Kickstarter project, and that's going to enable this to bring our price point down to $99 and really make an open platform. In return, for that favor, we're going to open source all our software, give it away for free, and open up all our documents and architectural reference manuals on the web. Getting the platform out there, we can put it in anybody's hands to innovate, to solve the parallel computing problem together.